Fieldwork exercise number 6, Trigonometric leveling. Introduction. Double-roded differential leveling is a method of determining the difference in elevation between points by employing two rods simultaneously. Two turning points are established such that at each setup of the leveling instrument, two sets of independent backsights and foresights are taken. Employing double-roded differential leveling provides a continuous check on the process of determining ground elevations while the work is in progress. The method is also useful when there is an urgent need to undertake differential leveling in a short period of time where no established benchmarks are available for checking results. Objectives: 1. To acquire and develop the skills of determining the vertical distances, the elevation and height of a remote point by applying trigonometric and related analyses. 2. To develop the skills of reading vertical angles using theodolite or total station. Instruments and accessories needed in this fieldwork are theodolite, leveling rod, markers, can be chalk or marking pins, measuring tape, plumb bob, and a range ball.
The procedures for this fieldwork exercise trigonometric leveling are: Number 1. Set up the theodolite at a convenient location and call it point A, where the leveling rod and the remote point are visible. Number 2. Using the telescope, take sight at the topmost remote point, then read the vertical angle and record as alpha on table number 5, trigonometric leveling. Number 3. Take another sight for the second trial. This is done to determine the precision of the observations. Number 4. Calculate the mean of the two vertical angles or the angle of elevation, not the zenith angle, of the specified point from the first station. Number 5. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight, that is the horizontal line or zero vertical angle on the rod, to determine the height of the instrument. Number 6. Transfer the instrument level towards the location of the remote point and designate it as Station B. Then measure its distance by taping from its initial position, Station A. Record this as distance AB. Number 7. After centering the bubble of the instrument level, sight at the same topmost remote point, which was sighted before, twice using the telescope, and record it as beta on table number 5, trigonometric leveling. After recording these two observations of vertical angle, calculate the mean. Number 8. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. And lastly, number 9. See the figure below. Analyze the right triangles formed to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvature and refraction.
Analysis of the figure above. 1. Determine the difference in elevation between two instrument setups, where difference in HI is equal to H1 minus H2. 2. Consider triangle B'EF, then solve for distance x using the tangent function, where tangent beta, where beta represents the angle, is equal to height 1 minus height 2 all over x. 3. Determine the sum of distance AB and distance x for the analysis of the oblique triangle A'FD. A'F is equal to AB plus x. 4. Consider triangle A'FD and use the sine law to determine the distance FD, where AB plus x all over sine beta minus alpha is equal to FD all over sine alpha. 5. Consider triangle FDG and determine the height of the remote point DG, where sine beta is equal to the quantity of height minus height 1 all over FD. Now you have performed the fieldwork exercise number 6, trigonometric leveling. Congratulations, because you made this far.